Hi everybody and welcome. Today we're going to be talking about linear programming. So your goal after watching this video should be able to identify the constraints of a linear programming problem and also maximize the objective function to basically using those constraints. So this is actually a really cool application of systems of inequalities because it's going to kind of set us up to use what we've been doing in definitive real world context. So constraints, these are things that we are going to look at as basically boundaries. So let's say, for instance, you only have somewhere between 5 and 15 hours a week to work. So you have to work more than 5 hours, otherwise you can't pay rent, but you have to work less than 15 hours, otherwise, if you're going to college, you won't be able to pass your classes. Beyond that, maybe you have a second constraint. So if hours are your x-coordinate, maybe there's something with your budget and how much you can spend on lunch at work that day, for example. So lunch is going to at least cost you some amount of money, but you can't spend more than $20 a day. Otherwise, it won't be profitable for you to go to work. Something along those lines. So that's the idea, is that your x value means something, your y value means something, and based off of those things in the real world, you're going to have things that basically hold you back from being able to just infinitely go on. So you can't work an infinite amount of hours, you can't spend an infinite amount of money on lunch. That's kind of the idea. So we can label these functions 1, 2, 3, and 4. And we actually need to graph each of these, and that's going to kind of give us a window that we're going to be looking into. So first things first, we can start off with our x is greater than or equal to 5. So let's set up a scale. Just for simplicity's sake, to make these numbers a little bit nicer to deal with here. So if x is greater than or equal to 5, this is function number 1. That means it is a solid line. It happens wherever x equals 5, and it's greater, so we're going to the right. So we'll label this right here as function number 1. Secondly, x is less than or equal to 15, so let's put that one here. Again, another solid line because of that or equal to sign. We'll label this as function 2. We shade to the left because it's less than. Our third function here, y is greater than or equal to 1x. We start off and we are going kind of one jump at a time here. Greater than or equal to, so another solid line. And this one is being shaded above. And this is equation 3. And then last one, y is less than or equal to 20. So wherever we are for 20, straight line across, less than or equal to, so this one again we are shading below. So using our constraints, we've just mapped what is possible. And what is possible is where the arrows are all pointing in, where everything is being shaded in. So this region right here is possible. We are allowed to work this amount of hours, spend this much money on our lunch based off of what we're working, basically. So now we have to, after we're at this point, go back and take a look at our function. So first things first, we have some corners of this region that we want to be careful to identify. But we are going to take a look here. And we're trying to maximize this R value function. It's called our objective function. And the key to these questions, if you could boil it down into 2 steps, would be graph your constraints and then plug in the corners of your constraints. So again, graph first, and then second, plug in. So we have 4 points to plug in, and we need to identify what each of those are. So we have 5, 5 here. We have 15, 15 here. We have to the right 15, and then up 20 here. And then we have to the right 5, and then up 20 here. So those are the 4 x, y, y pairs that we're looking at. So again, we'll write these down. And if you're like, Mr. R, how did you find those 4 points? Literally just plugged in the 4 functions and graphed them. So after you take your constraints and graph them, what we're really looking for, the whole reason why we did that graph was to get to these 4 values. All right, and what we're trying to do is we want to maximize our original function here, which is r equals 5x plus 10y, so our return. We want r to be as big as possible. So we're going to do this, you can probably guess, 4 times. See which of these 4 gets us our largest value. So again, directly taking these down, our x comma y ordered pairs, and translating them into what their values are. Okay, so let's go back to our function, and everywhere that we see these parentheses now, we're going to be plugging in each of those x comma y values. So 5 comma 5 here, plus 10 comma y here. That's our first one. Next one, 5 comma 5 here, and again, 10 comma y, which is now 20. Our next one, 5 comma 15, plus 10 comma, again 15. And our last one here, to me this one seems pretty promising, 5 comma 15, and 10 comma 20 this time. All right, so just calculator math at this point, plugging them on in to get our values. So 25 plus 50 for our first one, r equals 75. Again, just doing our distribution, doing a little bit of math there. Next one is 25 plus 10 times 20. Gets us 225. Well, that's quite a bit larger. We already know that that first one is not going to work for us now. We can eliminate that. 5 times 15 plus 10 times 15. Gets us also 225, interesting. And then our last one here, 5 times 15 plus 10 times 20. All right, looks like we found our maximum. So they might ask you for the max, they might ask you for the min. Just depends. We know that, this is our max value, so we're going to want to use that. So our max occurs when x equals 15, y equals 20. We have an r value of 275. And again, r value because that's our original equation, r equals. So this point right here, it looks like this top corner, that is our max value of our function. So again, just to reiterate, we are taking all of our constraints and graphing them, and then we are looking for the corners. So again, plugging in the corners of our constraint region. And once we plug that in, we're looking for either our max or our minimum value, depending on what the question asks us. So in this case, again, we have that answer of r equals 275, and it happens at this 4th corner, the top right corner. All right, so we're going to have a couple of questions here to practice, probably just 2 of them. Again, practice graphing those constraints and then plugging them back into the function that you're trying to maximize. And in a real-world situation, would actually give you the best possible option for whatever choice you're trying to make. As always, questions, comments, send us a message, email, book an appointment, any of those things. We want to help. And this is our skill for today. I'll see you in